So this is problem 2, test 2 from physics test of 2024. So for problem 2, it states that a slab filled with a uniform volume density of charge, P is greater than 0, occupies the region 0 is less than or equal to x, which is less than or equal to L, and extends indefinitely in the y and z directions as shown in the diagram. And so for the first part, we're trying to break the slab into an infinite number of infinitely large charged disks, each with thickness dx and charge density p dx. And so we're trying to write down and evaluate the integral for the net electric field when x is greater than L, and they give us the magnitude of the electric field produced by a single infinite flat disk. So where do we start with this? So we start with the formula they give us. So when x is greater than L, the magnitude for the electric field is equal to p dx over 2 epsilon naught in the x hat direction, the positive x hat direction. And then we want to integrate this to find the electric field. And since we know that the length is L, then we want to integrate it over this length of L to or from 0 to L. And once we pull the constants on the outside of the integral, we see that we're just left with x. And so after integrating and then inserting L for x, we find that the magnitude of the electric field for the net electric field is PL over 2 epsilon naught, still in the positive x hat direction. Alright, so for the second part of the question, we're finding the magnitude and the direction of the electric field on the other side of the slab. So where the electric field is less than, where x is less than 0. And if we can write down the answer without additional calculations, then we can do that too. So basically each slice of the slab has only the direction of its electric field flipped. So that means the net electric field or the integral can be negated. Thus the electric field here is just the negative, is the same magnitude as the net electric field, but in the negative x hat direction. And then finally, for the third question, we're determining the magnitude and the direction of the net electric field inside of the slab. So where x is greater than or equal to 0, but less than or equal to the length of the slab. So we know that that the net electric field inside of the slab is equal to the electric field where 0 is less than x, and then adding that with the electric field where x is less than L, and then we can apply our electric field formula and integrate from x to 0 and from L to x for each of the respective electric fields. and when we add those together and integrate, we get P times 2x minus L over 2 times epsilon naught in the positive x hat direction. But it's important to note that we can skip this step directly by noting that the answer to the first part shows the strength of a slab with uniform volumes densities field is linear in its thickness, and that means that the electric field where x is equal to 0 is equal to P times L over 2 times epsilon naught. So the first part of problem 2's solution. And then it's also important to note that when the electric field is 0, where x is equal to 1/2 of the length. So yeah, that's how you solve problem 2 for test 2.